welcome to today's class where we'll be looking at other examples on functions. Like in the last class where we treated composite functions and inverse of a function, we'll be looking at other examples on functions, how we can actually work on them using our idea of inverse of a function. So stay tuned as we go through this. Now we have an example here. The example says the following functions are given below. We have g of x equals to 3 minus x over 2x plus 5 and h of x equals to x squared minus 1. We are asked to evaluate, from our figure 1, g inverse of minus 2, and from our figure 2, we have to evaluate g inverse of h of x. So now, looking at the first thing we need to do here is bring out your parameters. So that you know what you are dealing with. You have g of x, 3 minus x over 2x plus 5. And then you have h of x, x squared minus 1. So for my figure 1 now, I'm asked to find g inverse of minus 2. First things first. We know that, first of all, we have g inverse, not g of x, not g of minus 2. We have g inverse of minus 2. So the first thing we have to get is actually to get our g inverse of x, first of all. So to get g inverse of x, the first thing we do is what? We introduce a letter or a variable to represent our g of x. So since we are using p in this case, as we did under inverse of a function, so our g of x now becomes p equals to 3 minus x over 2x plus 5. Then the next thing we do here, if you remember vividly, the next thing we do here for inverse of a function is what? We make x the subject of the formula. So making x subject of the formula, you cross multiply here, we have p into 2x plus 5 equals to 3 minus x. We have 2px plus 5p equals to 3 minus x. We have 2px plus x. Collecting like terms, we have 3 minus 5p. So the next thing we do here, since we want to make x out of a formula, we look at this place, we have an element of x here. We also have another element of x here. We just simply factorize x from both of them. We'll be left with 2p plus 1 equals to 3 minus 5p. Having this, the next thing I'm to do here is actually divide both sides by 2p plus 1. I have x, therefore giving me 3 minus 5p divided by 2p plus 1. So this is our value of x. But to remind you, this is not what we're looking for. We are actually looking for f inverse of x. So we remember to represent x with f inverse of x, p with x. Remember the procedure in the inverse of a function. So what do? Since we are going to be representing each of them, that means wherever I can see my x here, I simply put f inverse of x. Can I say? Therefore, my f inverse of x function will now be 3 minus 5. Instead of p now, I'll be using x. So 3 minus 5x all over 2x plus 1. So this will be my inverse function. But then I was not asked to find f inverse of x. Sorry, g inverse of x. I was asked to find g inverse of minus 2. So therefore, my g inverse of minus 2 now will simply be substituting my x for 2 in this equation. I'll have 3 minus 5 times minus 2 rather, they have 2 times minus 2 plus 1. This will give me 3 plus 10 over minus 4 plus 1. You know, minus 5 times minus 2 here will give us plus 10. And then we have 2 times minus 2 here, we have minus 4. 3 plus 10 here giving us 13. Minus 4 plus 1 giving us minus 3. So I can now say with confidence that G inverse of minus 2 will definitely give me minus 13 over 3. So that is that for our math figure 2. We are asked to find G inverse of h of x. For our figure 2, we are asked to find G inverse of h of x. That is what we are looking for in this case. So we have already gotten our G inverse of x. We already got our G inverse of x to be 3 minus 5 over 2x plus 1. So all we need to do now is recall that and then we use it. 3 minus 5x. And then for our h of x, we know our h of x is what? I think that's x squared minus 1, if I remember vividly. If I remember well. That's x squared minus 1. So that's x squared. So all I need to do here is the simple case of, this is a simple composite function. The only difference in this case is that what? The function g is not original g, it's actually the inverse of g. So we have gotten the inverse of g, which we need, and we also have our h of x. All you need to do here is substitute our h of x into the g inverse function. So how do we do that? So if g inverse of x is this, then I can say that g inverse of h of x will be simply g inverse of, what is our h of x? It's x squared minus 1. So since this is what we're looking for, I can just say that what g inverse of x squared minus 1, anywhere I see x in this space, I'll be simply representing it with x squared minus 1. So I just have 3 from here minus 5. Instead of x, I just put x squared minus 1. All over 2x. Instead of x again, I put x squared minus 1. Then plus 1. So this is all I have to do. And then I can expand my brackets and I get my final answer. This will give me 3 minus 5x squared minus 5 times minus 1, that's plus 5, all over, opening the bracket here, I have 2x squared minus 2 plus 1. Simplifying this further gives me 8 minus 5x squared over 2x squared minus 1. So I can say therefore my g inverse of what is 8 minus 5x squared all over 2x squared minus 1. And this then becomes my final answer. So that is all we'll be taking on this. So this is what we'll be taking on this. Till the next class when we'll take our last example on functions before we now move to polynomial. So see you next class, and do well to solve more questions as usual, because it is only then that you actually have a full knowledge of the subject matter. See you next class.